Welcome to Money Daily. Today, we're talking about an industrial revolution that's happening right now. At CES in Las Vegas, NVIDIA founder and CEO Jensen Huang delivered a keynote address. But this wasn't just another chip launch. This speech went far beyond hardware announcements. It was about redefining the very foundation of the computer industry. So don't miss today's episode.
Welcome to CES. Well, we have about 15 keynotes worth of material to pack in here. I'm so happy to see all of you. You got 3,000 people in this auditorium. There's 2,000 people in the courtyard watching us. There's another 1,000 people apparently in the fourth floor where there were supposed to be NVIDIA show floors, all watching this keynote. And of course, millions around the world are going to be watching this to kick off this new year. Well, every 10 to 15 years, the computer industry resets. A new platform shift happens. From mainframe to PC, PC to internet, internet to cloud, cloud to mobile. Each time, the world of applications target a new platform. That's why it's called a platform shift. You write new applications for a new computer. Except this time, there are two simultaneous platform shifts, in fact, happening at the same time. While we now move to AI, applications are now going to be built on top of AI. At first, people thought AIs are applications, and in fact, AIs are applications, but you're going to build applications on top of AIs. But in addition to that, how you run the software, how you develop the software fundamentally changed. The entire five-layer stack of the computer industry is being reinvented. You no longer program the software, you train the software. You don't run it on CPUs, you run it on GPUs. And whereas applications were pre-recorded, pre-compiled, and run on your device, now applications understand the context and generate every single pixel, every single token, completely from scratch every single time. Computing has been fundamentally reshaped as a result of accelerated computing, as a result of artificial intelligence. Every single layer of that five-layer cake is now being reinvented. Well, what that means is some $10 trillion or so of the last decade of computing is now being modernized to this new way of doing computing.
Jensen Huang opened his keynote with a very bold idea. He said that every 10 to 15 years, the computer industry goes through a major platform shift, from mainframes to personal computers, from personal computers to the internet, from the internet to cloud computing, and then to mobile computing. Every one of these transitions meant that the target platform for software changed, and the industry had to write entirely new applications for a new kind of computer. But this time, he pointed out something different. We are facing two platform shifts happening at the same time. The first shift is the AI platform shift. Software applications will be built on top of AI. At the beginning, people thought AI itself was just another application. But now, we are building new applications on top of AI itself. The second shift is a fundamental change in how software is developed and how it runs. The entire underlying stack of the computer industry is being reshaped. In the past, we wrote software to run on central processing units, CPUs. Now, we train software to run on graphics processing units, GPUs. Traditional applications were pre-written and pre-compiled. AI applications, on the other hand, are generated in real time. This shift from writing software to training software means the center of power in computing is moving. It's moving from CPUs to GPUs, and from traditional compiled logic to data and compute. Jensen Huang then spent a large portion of his talk showing how NVIDIA is responding to this double platform shift through extreme co-design. Because Moore's law has slowed down, the growth rate of transistor counts on chips can no longer keep up with the tenfold year-over-year growth in AI model scale. To solve this, NVIDIA had to adopt an aggressive strategy, redesigning every layer of the stack at the same time. And the most eye-catching part of this effort is their newest platform architecture, the Rubin architecture.
And now We've been shipping GB200s a year and a half ago. Right now, we're in full-scale manufacturing of GB300. And if Vera Rubin is going to be in time for this year, it must be in production by now. And so today, I can tell you that Vera Rubin is in full production. You guys want to take a look at Vera Rubin? All right, come on. Play it, please.
Vera Rubin arrives just in time for the next frontier of AI. This is the story of how we built it. The architecture, a system of 6 chips, engineered to work as one, born from extreme co-design. It begins with Vera, a custom-designed CPU, double the performance of the previous generation, and the Rubin GPU. Vera and Rubin are co-designed from the start to bidirectionally and coherently share data faster and with lower latency. Then, 17,000 components come together on a Vera Rubin compute board. High-speed robots place components with micron precision before the Vera CPU and 2 Rubin GPUs complete the assembly. Capable of delivering 100 petaflops of AI, 5 times that of its predecessor. AI needs data, fast. Connect X9 delivers 1.6 terabits per second of scale-out bandwidth to each GPU. Bluefield 4 DPU offloads storage and security, so compute stays fully focused on AI. The Vera Rubin compute tray, completely redesigned with no cables, hoses, or fans, featuring a Bluefield 4 DPU, 8 Connect X9 NICs, 2 Vera CPUs, and 4 Rubin GPUs. The compute building block of the Vera Rubin AI supercomputer. Next, the 6th generation NVLink switch. Moving more data than the global internet, connecting 18 compute nodes, scaling up to 72 Rubin GPUs, operating as one. Then, Spectrum X Ethernet Photonics. The world's first Ethernet switch with 512 lanes and 200 gigabit capable co-packaged optics scale out thousands of racks into an AI factory. 15,000 engineer years since design began, the first Vera Rubin NVL72 rack comes online. 6 breakthrough chips, 18 compute trays, 9 NVLink switch trays, 220 trillion transistors, weighing nearly 2 tons. One giant leap to the next frontier of AI. Rubin is here.
What do you guys think? This is a Rubin pod, 1,152 GPUs in 16 racks. Each one of the racks, as you know, has 72 Vera Rubin, or 72 Rubins. Each one of the Rubins is 2 actual GPU dies connected together. I'm going to show it to you. But there are several things that, well, I'll tell you later. I can't tell you everything right away. Well, we designed 6 different chips. First of all, we have a rule inside our company, and it's a good rule. No new generation should have more than 1 or 2 chips change. But the problem is this. As you could see, we were describing the total number of transistors in each one of the chips that were being described, and we know that Moore's law has largely slowed. And so the number of transistors we can get year after year after year can't possibly keep up with the 10 times larger models. It can't possibly keep up with 5 times per year more tokens generated. It can't possibly keep up with the fact that cost decline of the tokens are going to be so aggressive. It is impossible to keep up with those kind of rates if for the industry to continue to advance unless we deployed aggressive, extreme co-design basically innovating across all of the chips, across the entire stack, all at the same time, which is the reason why we decided that this generation, we had no choice but to design every chip over again. Now, every single chip that we were describing just now can be a press conference in all in itself. And there's an entire company who's probably dedicated to doing that back in the old days.
The arrival of the Rubin architecture was described by Jensen Huang as a massive leap at the frontier of AI. This is not a single chip. It's a system made up of 6 chips, designed as a unified whole from day one. So what's inside this system? First, a custom-designed CPU, built specifically for this platform. Under power-constrained conditions, it delivers twice the performance of the previous generation. Second, a next-generation GPU that is co-designed with the CPU. The two can share data bidirectionally and coherently at much higher speeds and with much lower latency. The performance gains of the Rubin architecture are staggering. It can deliver 100 petaflops of AI compute, 5 times more than its predecessor. But NVIDIA's ambition doesn't stop there. They understand that AI doesn't just need compute, it needs data, and it needs data fast. So alongside Rubin, NVIDIA announced a full-scale upgrade of the entire AI supercomputing system. Here are the key upgrades. First, Connect X9. It provides 1.6 terabits per second of networking bandwidth, ensuring data can flow at extreme speeds to every GPU. Then there's Bluefield. This data processing unit offloads networking, storage, and security tasks, allowing GPUs to focus entirely on AI computation. Next is the 6th generation NVLink switch. Its total data throughput exceeds that of the entire global internet. It can connect 72 Rubin GPUs together and make them operate as a single system. And finally, Spectrum X Ethernet. This is the world's first Ethernet switch with 512 ports, capable of scaling thousands of racks into one massive AI factory. Jensen Huang emphasized that achieving this required an enormous investment. NVIDIA deployed 15,000 engineers over multiple years. The entire Rubin system is built from 6 breakthrough chips, 18 compute trays, and 9 NVLink switch trays. It contains 2.2 trillion transistors and weighs nearly 2 tons. This is not just a hardware upgrade. It represents NVIDIA's core judgment about the future of AI competition. Whoever can train models faster will seize the advantage.
And then the last thing, of course, is performance. So let's take a look at the performance of this. These are only charts that people who build AI supercomputers would love. It took every single one of these chips, complete redesign of every single one of the systems, and rewriting the entire stack for us to make this possible. Basically, this is training the AI model, this first column. The faster you train AI models, the faster you can get the next frontier out to the world. This is your time to market. This is technology leadership. This is your pricing power. And so in the case of the green, this is essentially a 10 trillion parameter model. We scaled it up from DeepSeek. DeepSeek, that's why we call it DeepSeek++. Training a 10 trillion parameter model on 100 trillion tokens. Okay? And this is our simulation projection of what it would take for us to build the next frontier model. The next frontier model, Elon's already mentioned that the next version of Grok 5, I think is 7 trillion parameters. So this is 10. And in the green is Blackwell. And here, in the case of Rubin, notice the throughput is so much higher, and therefore it only takes 1/4 as many of these systems in order to train the model in the time that we gave it here, which is 1 month, okay? And so time is the same for everybody. Now, how fast you can train that model and how large of a model you can train is how you're gonna get to the frontier first. The second part is your factory throughput. Blackwell is green again, and factory throughput is important because your factory is, in the case of a gigawatt, is $50 billion. A $50 billion data center can only consume 1 gigawatt of power. And so if your performance, your throughput per watt is very good versus quite poor, that directly translates to your revenues. Your revenues of your data center is directly related to the second column. And in the case of Blackwell, it was about 10 times over Hopper. In the case of Rubin, it's going to be about 10 times higher again, okay? And in the case of now the cost of the tokens, how cost effectively it is to generate the token, this is Rubin, about 1/10. Just as in the case of, yep. So this is how we're going to get everybody to the next frontier, to push AI to the next level, and of course, to build these data centers energy efficiently and cost efficiently. So this is it.
In today's video, Jensen Huang first showed a chart comparing how long it takes to train a model with tens of trillions of parameters. He pointed out that time is fair to everyone. Time is the same for all of us. His own hair has turned gray. But whoever can train models faster and train larger models is the one who reaches the AI frontier first. Rubin's higher throughput means this. To train the same model, you only need 1/4 of the system size to finish in the same amount of time. That directly affects time to market, technological leadership, and pricing power. The second key metric is factory throughput. A $50 billion data center can only consume about 1,000 megawatts of power. If your performance per watt is poor, your data center's revenue will be capped. Jensen Huang pointed out that the Blackwell architecture already delivers 10 times the throughput of the previous Hopper generation. And Rubin will deliver another 10-fold increase on top of that. This means NVIDIA is using revolutionary hardware upgrades to help customers run their AI factories with higher energy efficiency and lower costs. The third key metric is token cost. The Rubin architecture can reduce the cost of generating tokens to 1/10 of what it was before. That means the cost of AI applications will drop dramatically, accelerating AI adoption and real-world deployment. Jensen Huang's keynote made one thing very clear. NVIDIA is no longer just a chip company. It is a full-stack AI company. From chips to infrastructure to models to applications, NVIDIA is reshaping every layer of AI. Their mission is to build the entire technology stack, so developers around the world can create truly incredible applications on top of it. This CES keynote was Jensen Huang's latest declaration of the AI industrial revolution. He told us that AI competition has entered a completely new dimension. It has moved from chip competition to system competition, and now to ecosystem competition. Through this extreme level of co-design, NVIDIA is securing its leadership position in the AI era. It's a strategy that is calm, calculated, and deeply ambitious. This time, Jensen Huang's keynote truly carried the presence and authority of a master, very much like Steve Jobs in his era. Thank you for watching. Thank you for spending your valuable time with my video. Feel free to share your thoughts in the comments. If you want to learn more about these topics, please hit the like button. Subscribe to Money Daily. Follow me for timely and accurate insights. I'll see you in the next episode.